All right, today we're jumping into a concept that's absolutely fundamental to how the internet works, subnetting. Now, I know, it sounds super technical, but trust me, we're gonna break it down. Think of it as the simple art of slicing a digital cake.
Welcome to Super Courseva. Unlock the secrets of the internet and master computer networking. Let's dive in.
But before we get to the solution, we've got to understand the problem. I mean, why do we even need to slice things up in the first place? Well, it turns out that when it comes to computer networks, bigger is definitely not better. In fact, one single gigantic network is just a recipe for disaster.
To really get our heads around this, let's step out of the digital world for just a second. Just imagine one single, enormous office building. Now, could you really have over 16 million employees all working in one giant open room? No departments, no reception, nothing. Just chaos.
And you know, that number, almost 17 million, I didn't just pull it out of thin air. That is the exact number of IP addresses you can have in what's called a Class A network, one of the biggest single networks possible. So our crazy office analogy, it's a perfect parallel to a very real problem in the digital world.
So what happens when you try to put almost 17 million devices on one flat network? Well, you get exactly what you'd expect in that giant office. Pure, unfiltered chaos. It just flat out wouldn't work. But why? What's actually breaking?
Look, this isn't just about things getting a little slow. We're talking about a complete catastrophic failure. The main router trying to handle 16 million conversations at once. It would literally overheat and melt. And forget getting anything done. If even one device sends out a broadcast message, a simple, "Hey, is anyone there?" all 16 million other devices have to stop everything they're doing just to listen. The whole network would grind to a dead halt.
So, how in the world do you solve this insane problem of a network that's just too big to function? Well, the solution is actually beautifully simple, and it's right there in the title. We slice it.
And that, right there, is subnetting. You take that massive chaotic network, our digital cake, and you cut it into smaller, more organized, and totally manageable slices. Now, each slice can do its own thing without creating chaos for everybody else.
And let's not get intimidated by the jargon, okay? Subnet sounds really technical, but all it means, literally all it is a short way of saying subnetwork. It's just a smaller network living inside a bigger one. That's it. Simple.
So to really see why these slices are so important, let's follow the journey of a single piece of data, what we call a packet, as it zips across the internet.
This is the key. Seriously, if you understand the path a packet takes, the whole logic of why we subnet is just going to click. So let's follow a package on its way to one specific computer inside a giant company.
Okay, so first, our packet is on the main internet highway. Think of this like a delivery truck. The truck only knows the main address, the company building. It doesn't care about individual employees, it just drops the package at the front door. That front door is the company's main router, our building receptionist. Now, the receptionist doesn't just shout the person's name to all 16 million people. No way. It looks at the packet and says, this is for the marketing department. That's the subnet. And finally, it sends the packet to marketing's own little mailroom, a smaller local router, which makes the final delivery.
You see? It's like a neighborhood. Each of those departments, or subnets, is its own little self-contained community. So now let's take a closer look at the traffic flowing in and out of one of these neighborhoods. There are just two simple terms you need to know here. Ingress is any traffic that's coming into our little neighborhood, and egress, you guessed it, is any traffic that's leaving it. This is how network admins keep an eye on the flow of data at every boundary. So here's the real magic. By creating these subnets, we've essentially created a bunch of independent mini-networks. Each one has its own rules, its own boundaries, its own performance. The chaos happening over in the sales department's subnet doesn't affect the engineering department's subnet at all. It's organized, it's efficient, and it's way more secure.
So now you get the why of subnetting. We do it to stop the chaos and create order. But of course, that leads to the next logical question: how is it actually done?
Well, the actual slicing is done with a few key tools. You've got things called subnet masks, which are used to define the size of each slice. Then there's CIDR notation, which is just a more modern, flexible way to write those sizes down. And underneath it all, there's a little bit of binary math to calculate the cuts perfectly.
And that leaves us with this final thought.
We figured out why we have to slice the digital cake to keep the internet from falling apart. The real art, though, the part that comes next, is deciding just how big each of those slices needs to be.